Okay, so the way AI video has worked until now is basically a relay race. One model makes the pictures, another model makes the sound, and then somebody spends an afternoon trying to line the two up so the footsteps land on the feet. Black Forest Labs shipped something in late July that refuses that whole arrangement. Flux 3 learns from images, video, and audio inside one architecture, and it generates the sound in the same pass as the picture. Let's talk about why that is harder and better than it sounds. The core design choice is easiest to see if you put the standard pipeline next to this one. The familiar approach generates visuals first, then hands them to a separate audio model that scores them afterwards. Alignment becomes a post-production problem, and it is a stubborn one because the audio model is guessing at events it never actually saw being generated. Lip sync and impact sounds are where this shows most obviously. This design learns images, video, and audio jointly inside a single architecture, so audio is produced in the same generation pass rather than added later. When the model that decides a door slams is the same model producing the slam, synchronization is not a step you perform. It is a property of how the thing was generated. Now, 3 specifics from the release are worth holding on to. First, length. Clips run up to 20 seconds, which sounds modest until you remember most generative video lives in 4 to 8 second fragments. 20 seconds is roughly where a shot can carry an actual beat, a setup, and a payoff, rather than being a moving texture you cut around. Second, resolution. It is released at 720p and 1080p. Worth being precise here rather than repeating the marketing, because resolution claims in this space get inflated constantly and the honest reviewers are still stress testing whether the 20-second claim holds up in practice. And third, the strange one. The same backbone extends to predicting physical actions, meaning robot control. A model that learned how the world looks and sounds turns out to have learned something reusable about how the world behaves, which is why video labs and robotics labs keep converging. Let's trace one prompt through the system, because the ordering is what makes this different from a pipeline. It starts with a single prompt, either pure text or an image you want brought to life. Both text-to-video and image-to-video run through the same model, which matters practically because teams usually need both and would otherwise be juggling 2 different systems with 2 different failure modes. Then generation happens jointly. The architecture was trained across images, video, and audio together, so the representation carries all 3 modalities rather than treating sound as an afterthought bolted onto a visual model. This is the actual research contribution, and everything downstream follows from it. The audio therefore arrives already synchronized, produced in the same pass rather than dubbed on afterwards. For anyone who has spent hours nudging a waveform to match a footfall, this is the part that changes the workflow, not just the output quality. And the same backbone extends outward to physical action prediction. That points at where these labs think the value is heading. Not just prettier clips, but a general model of how things move and sound that a robot could plan against. Alright, let's pin down what Flux 3 actually is. The model from Black Forest Labs is a multimodal flow model that learns from images, video, and audio inside a single architecture, rather than stitching separate specialist models into a pipeline. It generates clips of up to 20 seconds with synchronized audio produced in the same pass as the video, which removes alignment as a separate post-production step rather than merely automating it. Resolutions released are 720p and 1080p, and the same model covers both text-to-video and image-to-video, so a team does not need to run 2 systems for the 2 common entry points. And the same backbone extends to predicting physical actions for robotics, with the video and action capabilities in early access via API and private weights to selected partners. More releases taken apart at standarity.com.